What is up, everyone? Welcome to today's session. Today we will be discussing how to simplify exponential expressions. Now this is mainly going to be for the grade 11 phase, but grade 12s may need this, and grade 10s might be able to find some use in this as well. Just be careful of what you take and make sure that you follow your textbooks. Remember that we are based in South Africa, so we're running on our curriculum here. So let's get into it. So, the first thing we need to remember when dealing with this is our exponential laws, which were first told to us in grade 10. Noisy chair. We're still going to be using these now in this section. I have them written there for you. I'll see if I can keep them on the screen the whole time we are working. Just remember that all of these operate on the basis that a and b are positive values, and m and n are both integers. So there can't be any decimals in the m or the n. All right. So, talking about a few elements that are involved when we simplify our exponential expressions, there's three main things we should keep in mind. The first one is that we may directly apply these laws. So we may have a single standing value or expression with a single term, where these laws can just be directly applied to that term. Let's say, for example, we had something like this. If we apply our second law over here with the fraction, we see that if the base is the same, we can subtract the exponents because it's a fraction. So that will give us the same base of 5, the top exponent minus the bottom exponent. We then can simplify that exponent. We know that x minus 2x is equal to negative 1x. So we're now sitting with 5 to the power of negative x. We can then look at this law number down here, and we know that if we have a negative exponent, we drop it underneath the fraction. So 5 to the negative x will become 1 over 5 to the positive x. We generally want to express our exponents as positive values, not negatives. And there we are done with that example. The next thing we might be dealing with in this section is a fraction that has multiple terms in the numerator and or denominator. So I'll just put your fraction, multiple terms. And this splits into two pieces. The first one is that these terms might be multiplied together, or the terms might be added or subtracted. That's an M. So the best way to explain these is to go through examples. But there are two main things I want you to remember when considering these questions. The first one is that we generally want to break up any exponents that are added or subtracted. Okay, now that we can see here from law 1. Most people will think that you can only go one direction with these laws, but we can actually reverse them as well. If we're in a situation where we have a to the power of m plus n, we could rewrite that as a to the m times a to the n. And we are going to use that in these examples. The second thing I want you to think about is decomposing any numbers into their simplest prime values. For example, if we had 4 to the power of x, it is often going to be beneficial to take that 4 and break it down further as 2 squared to the power of x. We can then use law 3 over here. Is that law 3? No, law 5. Whichever law that is, this one. We can then rewrite that. Because we have the exponent outside the bracket, we can now say that it's 2 times x. So 2 to the power of 2 times x. 2 to the 2x. All right? And this idea of decomposing into prime factors can be done for most of the values that you will see in your questions. For example, 81 we can think of as 9 times 9. Or if we wanted to, we could write that as 9 squared. But 9 times 9, each of those 9s can be seen as 3 times 3. So each of those 3 pairs is one of the 9s. So we can actually take 81 and decompose it all the way down to be 3 to the power of 4. Alright? So this combination of breaking up exponents that are added or subtracted using this law 1, tied in with the idea of decomposing any bigger numbers into their simplest prime factors. Those two things together are going to help us solve these problems. So let's talk about that. So we're going to discuss these by using examples, so you can see exactly what I meant by everything that I've said. First things first. Ed, throw me an example there. Let's do one with multiplication.
All right. 2 to the 9a times 4 to the 6a times 2 squared. All of that over 8 to the 5a.
All of that over 8 to the 5a. You can see it, right? Is that what it's got?
2 to 9a, 4, 6, 2, 2, 8, 5. Yes.
Okay, cool. So let's go through this one. This is actually a good choice of example there, because I want you guys to see here. This is scary. This is dangerous. I do this as well. Be careful that your 9s don't look like A's, because that could really mess up, firstly, your steps. Could also confuse the marker as to what you've written. So make sure your 9 gets a nice big tail there, or if you often write it as that other curvy version that looks like a G, then do it that way, Just make sure you distinguish between 9s and A's. In the same way, make sure that you distinguish between 2s and Z's and 5s and S's, because sometimes when you're writing quick, 5s and S's might look similar, or 2s and Z's might look the same, so create some kind of distinguishing mark there. That wasn't part of the video, that was just something that popped in my head now. So, back to our example. So let's take what we've said. First things first, I'm going to take all of these values and decompose the numbers into their prime factors. Now, I didn't mention this before, but the reason we do that is because we always want our bases to be the same. If we look at our exponential laws, we see that in all of these cases, the A's are the same. A at the top and the bottom, A there, all right? If we have two different bases, here you see A and B, we can't put them together. So that affects our maths. Okay, so let's decompose these numbers into their prime factors so we can see if we can get all the bases the same. So 2 cannot be broken down any further. I'm going to keep that as 2, 9a. 4 we see can be broken up, so I'm going to make that 2 squared, and then we still have the 6a over there. The last value there, obviously 2 cannot be broken up. We're just going to keep that as 2 squared. The bottom of our fraction, we see that we have an 8. Now, as long as we know our cube numbers, 8 is the same as 2 cubed. And then, of course, we still have the 5a sitting there. All right. Now I'm going to use this law over here to multiply our bracketed exponents there. So this expression will now become 2, 9a times 2. And then here we have 2 times 6 is 12. So that's 12a. And then we have our 2 squared just sitting there at the end, watching everything happen. Denominator, we will take the 3 and multiply by the 5a. So 3 times 5 gives us 2 to the power of 15a. All right, looking good. And we can track which laws we use. The more you practice these types of questions, you'll actually find that you stop looking at the exponents list. You'll start remembering them as you go. Let's change colors on board of black. So, the next law that I'm going to use is the first one. Now that I've gotten all the bases the same, I want to be putting all my stuff together so I can actually start simplifying this. So we see that on the top, the 3 terms that are multiplied, the base is 2, which will stay the same according to law 1 over there. So we will then add all of our exponents together. We have 9a plus 12a plus 2. And that will all be divided by the bottom, which is 2 to the 15a. Now what I'm going to do is at the top, I'm just quickly going to combine those exponents. So 9a plus 12a is 21a. So 2 to the 21a. Now we can't add the 2 in because the 2 doesn't have an a with it. So we're going to leave it like that. I'm now going to use our fraction law there, or division law. And we're going to take the top exponent, subtract the bottom exponent. So that will become 2, 21a plus 2 minus 15a. If we simplify that, we have 21a minus 15a gives us 6a. So we have 2 to the power of 6a plus 2. All right, let's look at the other type of example where our terms in our fractions are added or subtracted. Ed, throw me an example there. Pick one that has pluses or minuses in the numerator and stuff.
Alright, so we can go with 3 to the m.
3 to the m.
Yes. Minus 3 to the Milo plus 1.
I love Milo.
Over 4 times 3 to the Milo minus 3 to the Milo.
Like that?
Yeah.
Okay. All right. That's a good example. Okay. So going through this now, we have to introduce another thought. First things first, we stick to what we've said before. We first check, can we decompose numbers into prime factors? And secondly, can we separate exponents that are added or subtracted? So let's go through that phase first. 3 to the m cannot be changed because there's no addition or subtraction there in the exponent, and 3 is already a base prime number. Subtract. Okay, now here we have m plus 1. So I'm going to use the first law there and change that into 3 to the m multiplied by 3 to the 1. All right, so we just used that, let's call it the reverse of that exponential law there. At the bottom, my fractions are mixing into each other here a little. At the bottom, we have 4 times 3 to the m minus 3 to the m. So I'm going to take that 4 and change it to 2 squared, just for the sake of sticking with the bases being prime numbers. Then we're multiplying that with 3 to the m. I cannot manipulate that at all. And we subtract 3 to the m. I cannot manipulate that either. All right, so I've changed the bases to prime values. I've separated exponents that have pluses or minuses. Now comes in our next thought. When you're at this point, when you see the pluses or the minuses, particularly in the fractions between terms, so these minuses here are our indicators. Remember, those could be pluses. This is when I want you to think common factor. All right, we have to factorize this expression in order to simplify it. So, in our numerator, we see that between those two terms, the common factor is going to be this 3 to the power of m over there. So in our numerator, I'm going to take 3 to the m out of the bracket. And here we are left with 1, because there's nothing else multiplied with the 3m, minus, here we are left with 3 to the power of 1. All right, taking that 3m out, that's what we have in our numerator. In our denominator now, we're going to do the same thing. We're going to factorize, and we see that once again, our common factor is this 3 to the power of m. So if we take that 3 to the power of m out of the fraction, what's left behind? We have 2 to the power of 2 minus nothing, or 1, because when we take 3 to the power of m out of there, this is just silently multiplied by the 1, which will be left behind. All right. Obviously, that requires you to be quite practiced with your factorization. I do recommend going back and looking at that all again. In this case, we used common factor, but it is possible that you may have to use trinomial or difference of squares as well. So go revise your factorization techniques. We'll probably do a video at some point on that. All right, now that we have completed our factorization step, all that's left is to simplify. So we see here now, because these are multiplied, we can cancel out the top and the bottom of the fraction. We couldn't do it before because we had those subtractions in there. And that's why we had to factorize. But now that those are all multiplied, we can just cancel top and bottom. So this 3m is going to cancel out with that 3m into nothing. And what we are left with is 1 minus 3, because 3 to the power of 1 is just 3, divided by 2 squared minus 1. Now I'm actually going to take that 2 squared and write it as 4 again, because now we're just dealing with numbers. So this becomes a much easier fraction to deal with. So at the top, 1 minus 3 gives us an answer of negative 2. At the bottom, 4 minus 1 gives us an answer of 3. And there's our final answer. This exponential expression at the beginning simplifies all the way down to just equal negative 2 over 3. A couple of tips here. If you reach this stage and your variables did not cancel out, you may have made a mistake, so just double check your steps. As you see there, my 3 to the m's removed each other. Alright, so you generally want to be in a place where you're only dealing with numbers here. 99% of the time that's true. It may be hornet, wasp. It may be possible that you would still have a variable there, so just don't assume you're wrong. I just want you to check your steps and make sure you didn't make any mistakes. Alright, great. And that concludes our video for simplifying exponential expressions. Keep in mind that I did some pretty basic examples in this video, so I need you guys to practice as much as possible, especially when it comes to using different factorization techniques. Please comment down below when you find examples that you struggle with, or if you need me to clarify anything further. Remember to share the video, like, subscribe if you haven't already, and we'll catch you in the next one. What is up, everyone? Welcome to today's session. That might have been too loud, eh? Cut.